Hi, and welcome to this walkthrough clip of a level of response question on rate constant and construction of a two-step mechanism. Let's look at how the question might be processed first. So looking at the question in its entirety, you can see there's an equation and there's also some initial rates data. You're asked to determine the rate constant and a possible two-step mechanism, so it's important to bear in mind both of those must be addressed in your answer. The rate equation is what you're looking for in the first part, because the rate equation will contain the rate constant K. So what we need to do is work out the order of reaction with respect to each of the reactants, and then you can put the relevant power next to each concentration term in your rate equation, and then rearrange it so that K is the subject. So let's start with that part first. The trick here is to look for pairs of experiments where only one concentration is changing. So this will therefore be the only factor affecting any change in rate. So if we look at experiments 1 and 3, you can see quite clearly that iron 3 plus concentration stays the same, the iodide ion concentration doubles, and the result is the rate created by 4, so it's second order with respect to I minus. Looking again at experiment 1 and 2, this time round it's the I minus concentration that stays the same, but the Fe3 plus concentration doubles, and the rate doubles. So therefore it's first order with respect to Fe3 plus. So therefore we now know that the concentration term for Fe3 plus is raised to the power of 1, first order, and the concentration term for I minus is raised to the power of 2, second order. So we choose one experiment. I'm going to go for experiment 3. It doesn't matter particularly which one you choose because the numbers should lead to the same value. So you sub the numbers in, making K the subject first, of course. So 3.24 times 10 to the minus 3 goes in at the top, and at the bottom, the values for each of the concentration terms, not forgetting to square the iodide, like so, and that will give us 22.5. Now, not forgetting the units as well, mole per decimeter minus 3 seconds minus 1 per rate, and each individual concentration term carries moles per decimeter minus 3, so 3 of them will multiply to make moles to the power of 3 decimeter minus 9, cancelling through will give you mole to the power of 2, decimeter to the power of 6, second to the minus 1. So the next thing to have a look at is a possible two-step mechanism. So I'll talk you through it. Just to remember, there's several different possible ways of writing this out, but there's a few things that stay the same. So I'll make sure that I sort of give you guidelines as to what has to happen each time you do a two-step mechanism. Right, first of all, the overall equation must be represented by both of the steps, fast step and a slow step. We know that the rate equation carries a certain ratio of orders, and that ratio of orders will match the stoichiometry or mole ratio to reactants in the slow step. So therefore we have 1 Fe3 plus and 2 iodides in the slow step. Now, the products in the slow step must get used up in the fast step, so we have a bit of flexibility here. Provided they get used up in the fast step or end up in the products of the overall equation, and the overall equation doesn't change the result, we can put in a number of different things here. So, I'm going to propose that in the first one, you put Fe2 plus as a product and I2 minus, so 2 iodine atoms combine together, but it doesn't make a molecule, it makes an ion. So I'll try and explain why I've chosen these. Like I said, there are other options that are available. So I'm choosing Fe2 plus because you need a total of 2 moles of Fe2 plus in the products, and there's only one in the fast step. So I need another one made in the slow step, so together they make 2 Fe2 plus. I2 minus, because you need a species that balances the 2 iodide ions, but 1 electron has been lost to reduce Fe3 plus to Fe2 plus. Okay, now, next thing to do is to cancel everything out. So it ends up I2 minus gets cancelled. It doesn't turn up in the products anywhere and in the overall equation. So if we now combine the slow step and the fast step, we get the overall equation we're given with, that we're provided with to start with. Okay, that's it. Thanks for listening. Until next time, see you soon.